You're in the cabin. The seatbelt sign comes on. The aircraft starts descending. Outside the window, clouds. Nothing but clouds. No runway, no ground, no visual reference whatsoever. And yet the aircraft continues descending. Precisely, steadily. On a path calculated to within meters. You can't see where you're going. The pilots might not be able to either, so how does a 70-ton aircraft find a runway it cannot see? And land on it safely? That's what this video is about. It starts with the ILS, the Instrument Landing System, a ground-based radio navigation system that gives the aircraft two critical pieces of information simultaneously. The first is the Localiser, a horizontal signal transmitted from the far end of the runway that tells the aircraft, are you left of center line, right of center line, or perfectly aligned? The second is the Glideslope, a vertical signal transmitted from beside the runway threshold that tells the aircraft, are you too high, too low, or on the correct descent path? Together, the Localiser and the Glideslope create an invisible electronic corridor in the sky, a precise path that leads directly to the runway threshold. The aircraft follows that corridor, all the way down. So what does that look like from inside the cockpit? The pilots are monitoring two needles on their instruments, a vertical needle for the Localiser, left or right, a horizontal needle for the Glideslope, high or low. When both needles are centered, the aircraft is exactly on the ILS on track, on path, descending at 3 degrees towards the runway. That 3-degree glide slope is standard for most commercial runways worldwide. It translates to roughly 300 feet of altitude loss per nautical mile. Steep enough to descend efficiently, shallow enough to give the aircraft time to stabilize and the crew time to manage the approach. Every second on that glide slope, the aircraft is getting lower, the runway is getting closer, and the crew is making a decision. That decision comes at what's called the decision height, or the minima, a specific altitude set before every approach, below which the aircraft cannot descend unless the crew has visual contact with the runway environment. At decision height, there are only two options. The runway is in sight, continue to land. The runway is not in sight. Go around, immediately. No hesitation, no second attempt at that altitude. The go-around is not a failure. It is the correct trained response to an aircraft that has reached its limit. Decision height varies depending on the category of the approach, and that's where the categories come in. ILS approaches are divided into categories based on how low the aircraft can descend and how little visibility is required. Category 1, decision height 200 feet. Runway, visual range 550 meters. Category 2, decision height 100 feet. Runway, visual range 300 meters. Category 3A, decision height 50 feet. Runway, visual range 200 meters. Category 3B, decision height below 50 feet. Runway, visual range as low as 75 meters. Category 3C, zero decision height. Zero visibility, a full blind landing. Each higher category requires more sophisticated aircraft systems, certified runways, and specifically trained crews. Not every aircraft can fly a Cat 3 approach. Not every airport is certified for one. Category 3 operations, particularly Cat 3 B and C, require the aircraft to land itself. Autoland. The autopilot maintains the ILS track all the way to the runway surface. No human hand on the controls at touchdown. This is not because pilots can't land in low visibility, it's because at 75 meters of runway visual range, roughly the length of an Airbus A320, the human eye simply cannot react fast enough to correct deviations at landing speed. The automation is more precise, more consistent, more reliable in those conditions. Autoland is not a shortcut. It is the engineered solution to a visibility problem that human senses cannot solve alone. Just before touchdown, whether manual or automatic, something happens that every passenger has felt, but most have never understood. The flare. As the aircraft approaches the runway surface, the nose pitches gently upward. The rate of descent reduces. The aircraft settles onto the runway rather than driving into it. On a manual landing, the pilot pulls back on the controls at the right moment, judged by feel, experience, and visual cues. On an Autoland, the flight management system executes the flare automatically, triggered by radio altimeter readings as the aircraft crosses the threshold. That gentle nose-up moment is the difference between a smooth touchdown and a firm one. It is one of the most precise and perishable skills in aviation. Touchdown is not the end. The aircraft is still doing 250 kilometers per hour on the runway. It needs to decelerate to taxi speed, around 30 kilometers per hour, in the distance available. 3 systems work simultaneously to make that happen. Thrust reversers, the engine nacelles redirect thrust forward, acting against the direction of travel. Spoilers always eyeing, panels on the upper wing surface deploy immediately on touchdown, destroying lift and forcing the full weight of the aircraft onto the wheels. Brakes. The wheel brakes apply hydraulic pressure to the brake assemblies on the main gear. All 3 activate within seconds of touchdown. The passenger feels the deceleration, the noise, the pressure. That is 3 engineered systems doing exactly what they were designed to do. The next time you're on approach in cloud and you feel the aircraft locked onto that steady, precise descent, that's the ILS. The next time the seatbelt sign comes on and the cabin goes quiet, that's the crew managing an approach to minima. The next time you feel that gentle nose up just before the wheels touch, that's the flare. And the next time you feel the roar of reverse thrust and the weight pushing you forward in your seat, that's 3 systems simultaneously scrubbing off 250 kilometers per hour in under 2 kilometers of runway. You are not a passenger on a metal tube hoping for the best. You are sitting inside one of the most precisely engineered sequences of events in the world, every single time. So next time you're sitting by that window watching the runway appear through the clouds, you'll know exactly what brought you there. If this changed how you think about landing, hit subscribe. I break down aviation in a way that actually makes sense. See you in the next one.